today we're doing section 1.3, which is really about how do we find limits algebraically. Yesterday we found limits using a graph and using a table. Today we're going to find limits algebraically. Those are your three requirements or settings for every calculus problem. Every problem you're presented with will be in one of those three settings. It'll either come from a graph, a table, or a function, algebra, right? So today what we're doing is algebra. Now, I want to show you really quickly the rules. I don't want to spend a lot of time with you guys writing down the rules. I'm just going to show, I'm going to blast them on the overhead. But I'm not going to spend a lot of, I don't want you guys to spend all the time copying. Because what happens is we copy all these rules, no one ever looks at them again, and they're not, what you'll do is you'll get the gist in the context of the problems anyway. So what I'd rather do is focus more on working the problems instead of memorizing the rules. These you don't have to memorize. Well, except for the first one. I'm going to skip the first one for a minute. Let's just pretend that the limit as x approaches c of f of x is big L. All right? C is some number. So this limit is big L. The limit as x approaches that number of g of x is big K. So here's what you can do when you have a limit. If you take a function and multiply it by a scalar, you can take the limit and multiply it by a scalar. So a number times a function, number times the limit. If you're adding two functions together, you can find each of their limits separately and add them together. So this, the sum of the functions, the sum of the limits. If you if you're multiplying two functions together, you can multiply their limits together. If you're dividing two functions, you can divide their limits as long as you're not dividing by 0, right? If you raise a function to a power, you can raise the limit to a power. So what this is saying is, if you have some function, let's just say for this last example, say you have some function like x plus 2 quantity squared. You can find the limit as x approaches whatever of x plus 2 and then square the limit, rather than squaring it all out first and then finding the limit. Right? So you can apply, most of these straightforward algebra rules apply to limits. Yes?
What if it was like f of g?
That's a good question. We will get into composition, but not today. Okay? Alright, so we've got all of this. Here's one rule though that you do need to know, which is that the limit of a constant is the constant. If you want to write it down in words, if you want to write it down in symbols, the limit of a constant is the constant, no matter what. So if I say, for example, what is the limit as x approaches negative 286 over 11 of 12? The answer is 12. It doesn't matter what x is approaching, the limit of the constant is the constant. Now the reason why is if you have the horizontal line, y equals 12, then no matter what x value you're at, the y value is going to be 12, right? So if I have the line y equals 12, it doesn't matter where I am on the line, my limit's going to be 12. Does that make sense? So the limit of a constant, remember constant functions of horizontal line, limit of the constant is always the constant, no matter what. Alright, so the limit as x approaches c of b is b.
What about a vertical constant?
A vertical constant?
Or like just like y or x equals.
You can't have a limit as x approaches, I don't even know. Yeah.
It wouldn't
yeah.
be a function.
Yeah, it wouldn't be a function and that would be confusing. Okay. So certainly that limit would not exist. Alright, so let's get into some actual examples. Okay. First thing I want to talk about is that for all polynomials, and really for any continuous function, if you want the limit, you can just plug the number into the function and that's your limit. Whenever a function's continuous, then the value of the function and the value of the limit are the same. So for a couple quick examples, I'm going to Turn this light on and see if it helps the video. Okay, so for a couple quick examples. If we had the limit as x approaches 2 of x squared plus 3x. Alright, so is x squared plus 3x a continuous function?
Yes.
Yeah. All polynomials are continuous, right? Okay, so I just plug the 2 in, I see what I get. I get 4 plus 6, the limit is 10. Does that make sense? Now, if you think about the rules we just used, were you thinking that this was actually f of x plus g of x, and this is g of x multiplied by a scalar of 3, and this is f of x raised to the second power, right? That's what I'm saying. Like, no one thinks about the rules when they're doing limits. They just do it, right? Okay, so you actually used a whole bunch of rules in there, but it's really, for most part, just you can just do the algebra and it'll be fine. All right, so I'm going to give you guys 3 problems I want you to do in your groups right now, and we'll see how you do. I know we're not really doing trig right now, but I'm going to throw one trig one at you just for fun.
Why are you so mean?
Oh, okay. All right, so in your groups, take a moment, figure out each of these, and then once you have an answer for all 3, make sure you all match. Every member of your group should match. If not, you'll need to figure out what's up.
Wait, I got a negative 9.
I didn't somehow.
Sure. Multiplying cosine pi. Cosine pi minus x. Cosine pi. This is so yeah, A is 5. That's it, it's a constant, there's a constant, which is a
For C, I got negative 5.
and then for B, you guys get well, what's 3? Oh, it's negative 1?
Cosine pi is negative 1. No, I'm saying which one first. Yeah, negative 3 plus 2. Negative 4 is negative 5. I thought it was a 1. My brain is negative 5.
You see what we got done?
Okay, so you need another minute?
Stuff
Have you guys all checked with your groups? All right, so for letter A, what is the limit as x approaches 2 of 5? 5. It's 5. What do you think is the most common mistake for these problems?
2.
Putting the 2 down, right? Yeah, it's not the x value. Limits are y values, right? They'll never be the x value. Limits are always the y value. All right, for this one, ooh, those negatives. So we get, is this positive or negative 3?
Negative.
Negative 3
Plus
minus 2, right? Because negative 1 gets squared. So negative 3 minus 2 is negative 5. Minus 7 is negative 12. Plus 4 is negative 8. Okay, those darn negatives. Did the whole group miss that one?
Yeah.
Oh,
Well,
no.
I thought it was a positive one, so I got 12.
Oh, you like thought you were plugging a 1 for the whole thing.
Yeah, I just didn't see I thought that was like a continuation from the arrow.
Oh,
Because I wrote it down like that in my book.
I'm sorry.
Yeah.
Okay. Do you get it now?
Yeah.
It's good. All right. Okay, so if we plug in a pi for x, we get pi cosine pi. In this class, you are not allowed to leave any trig values unsimplified. So if you get down to cosine pi, you need to tell me what the cosine of pi is. What is the cosine of pi? It is -1. Remember, psi y, coho, cosine is your x value. We're talking about at pi, it's out here, so we're at x equals -1. So the answer is -pi. How'd you guys do with those? Those okay?
We own those.
Any questions? Good. All right, the next thing that we're going to talk about, which is actually the majority of your homework, is on canceling. So I want you to put this in your notes. Let's see here. I'm going to put it right there. Sorry. Okay. Sorry, I'm going to rewrite again. If you plug in, and I apologize, this is not correct math jargon, that's okay. If you plug in and get 0 over 0. So say you plug the x value into the function and you get 0 over 0, keep going. Keep going. In limit world, 0 over 0 means keep going. The limit exists for 99.9% of these cases. So if you plug in and get 0 over 0, keep going, the limit exists. What you have to do is cancel common factors. What'll happen is when you plug in and get 0 over 0, that means that there's going to be a factor, top and bottom, that's the same, and you're going to need to cancel it. Once you've canceled it out, then you can plug in and you should get a regular numerical answer. Now, in order to do some canceling, that means we have a lot of factoring to do. And some of you need to work on your factoring. Looking at your tests, there were some of you who factored things just fine, and there were some of you who really struggled with the factoring. There was a lot of factoring on that test. Do you guys recall that? There were at least 3 or 4 problems that needed to be factored. So, and there will be a lot of factoring throughout this year. So if you're not comfortable factoring, that's something you should really practice. There are a million websites where you can go out there and practice factoring. So do some factoring practice, although I'm going to give you a lot of factoring tonight, so you'll get a lot of factoring practice tonight. Before we start factoring though, there are 2 factoring rules that I'm just going to refresh your memory on just in case you forgot. And they are the sum and difference, I'll do A, of 2 cubes. You have to know how to factor sums and differences of cubes. So you have to be able to factor quadratics. Quadratics come up more than anything else. But cubics do come up. So you have to be able to factor sums and differences of cubes. When you factor cubes, whether it's a sum or a difference, you take the cube root of the first term and the cube root of the second term. Then you take this cube root, this first term that's in this binomial here, and you square it. And you take the second term and you square it and you write it at the end. So this gets squared and this gets squared. And then you multiply these together for the middle. So I think square the first, square the second, multiply middle. The only thing that's different about the 2 are the signs. Does anyone remember how we figure out the signs? Soap, right? Same, opposite, always positive. Same, opposite, always positive. Okay? There will be cubes. So if you've forgotten how to factor a cube, make sure you write the rules down and practice a little bit. I'm gonna give you one to start with. Let's take a look at the problem that we got yesterday. We made a table for it. It was x cubed minus 1 over x minus 1. If we substitute a 1 in for x in this function, what do we end up with? 0 over 0. And in limit world, what does 0 over 0 mean? It means keep going, the limit exists. So what we're going to have to do is factor in order to see what we can cancel. Can I cancel an x right now just as this stands?
No.
No, that would earn me a big BA and a minus whatever it is that the problem is worth, right? Okay, so instead, and by the way, every time you do additional work for a problem, like you have another step, you have to rewrite your limit statement. You have to rewrite that limit statement all the way until you plug the number in. Once you plug the number in, you don't have to. There are mathematical reasons why, that I will tell you about in a moment. But what I want you guys to do right now is take a second and factor the top, and then rewrite the bottom. Yeah, sure. Remember, when you're working, you can talk. That's okay. You don't have to be silent. Everyone have it factored?
It's negative 1.
Yeah, no.
Oh, I know. It's minus x. So it's minus x plus
Alright, a little hint. If you plug in and got 0 over 0, that means that one of the factors on top has to be what? X minus 1. Right? So if you've forgotten how to factor cubes, at least you've got that going for you, right? You know x minus 1 has to be one of the factors. Alright, can anyone tell me what's left?
X squared minus
X squared
Plus x.
plus x plus 1. Okay? Same, opposite, always positive. How'd you guys do on the factoring? So, okay. Cancel. Once you've canceled top and bottom, plug in again and see what you get. So now if we plug the 1 into our function, what do we get? 3, which, by the way, is the y value of the hole on this graph, right? So if you were to graph this, since the limit exists, there has to be a hole there, not an asymptote, right? So since there's a hole there, if you ever want to know the y value, you get it by canceling the common factors, right? Plugging in. So that's the y value. And that's the value of our limit. All right, let's do a few more where you guys practice factoring and canceling in order to find the limit. By the way, not all of these require factoring and canceling. Some of them you should always start by plugging that number in, because sometimes you get just a normal nice answer without even having to factor. Yes, guys, this is, all right, very sorry. Okay, this first one's the limit as x approaches -2 of x squared plus 5x plus 6 over x plus 2. The next one is the limit as x approaches 1 of x squared plus 5x plus 6 over x minus 1. Then we have the limit as x approaches 3 of x squared minus 4 over x plus 2. And the limit as x approaches 2 of x squared minus 4 over x plus 2. I guess I should also do a limit as x approaches -2 just for fun. If we have time. We'll do the limit as x approaches -2. X squared minus 4 over x plus 2. Okay, so take a couple minutes in your groups and work these 5 problems. See how much time we have. You get 2 minutes. Go.
What for all?
Yep, you can do this.
I feel like the hardest part is writing them all down.
Yeah, I can live that.
Yeah.
Shut up.
B.
E undefined.
If we know that there's like gonna be
Oh, I see. Yeah.
0, 0, do we have to like plug it in and see that
You don't have to prove anything. If you want to
It's
just
like
go ahead and jump to
automatically-
factoring, that's fine.
Oh wait, yeah, 9 minus 4. Yeah, I had it wrong. 9 minus 4 is 5, yeah, 1.
Yeah, you're on the bottom, but it's not,
No,
X minus 4 is 5.
4 minus 4. Yeah. 0 shouldn't like be factoring for
E, you have to do x plus 2, x minus 2.
Yeah. -2 plus. Oh yeah, you're right.
Yeah, 1 undefined, 1, 2.
Just leave it and move on.
You don't have to factor this 3 minus 2. And -4 in the last one.
Yeah.
Is that done?
We're done.
No, why you gotta think over? I was asking, how would you feel? Like we're waiting on
We
this.
got it.
Good, fantastic. Okay, so I'm gonna quickly move on. Because we don't want to run out of time.
Yeah, because this year I'm trying to be organized.
So if we plug in this -2, we ended up with 0 over 0, right? So we factor x plus 2, x plus 3 over x plus 2, x plus 2's cancel, and you plug in and what is the limit? 1. Any questions on letter A?
Negatory.
I just plugged a -2 in for my x. Yeah, does that make sense? Good. Any questions from the back? That's good. On this one, if I plug in, what do I get? 12 over 0. Now, does 12 over 0 mean keep going? No. 12 over 0 means there's a vertical asymptote. This thing does not exist.
What?
What?
Wait, is it? That's how you do it.
For limits, you say that the limit does not exist.
Did you have to put the, y? If you
Not for tonight, not for the algebra.
Okay.
Okay, for this one, if we plug in, we get 5 over 5, the limit's just 1. Did you next factor? Did you guys all get that?
Yeah.
Okay, for this one, we plug in, we get 0 over 4. Hey, 0 over 4, what does that equal?
0.
0 is just a normal number like any other number. That limit is 0.
You get -4.
Okay, this one, we get 0 over 0. We're going to have to do what?
X plus 2.
What's our favorite F word?
Factor.
Factor.
Friends is my favorite.
Oh, that's good. Okay. So we end up with a limit of -4. How are you guys feeling about these?
Perfect.
Okay?
Easy.
Boy, tonight you are going to have so so much fun.
So excited.
Factoring, right? That is all you're gonna be doing.